PMD, you will get the request from the customer for network or links where data rate is minimum 10 gigabit per second. If it's below, CD-PMD is not necessary, so it will come only when we start talking about 10 gigabit per second or 40 gigabit per second. 40 gigabit per second are mandatory. CD-PMD, you have to do it. For 10 gigabit per second, only chromatic dispersion is mandatory. PMD in some cases. But as soon as someone asks you for chromatic dispersion, then you are not going to sell him chromatic dispersion tester only. You can tell him, I'm sure next year you will need PMD, buy the whole package, I propose you CD and PMD. We do have several solutions. So before going to the instruments, I wanted to show you what we have in terms of offer, JDSU offer, what you can offer. Because sometimes it is a bit complex. 5 different modules depending on what the customer wants. So we have a module for PMD only, for PMD and spectrum analyzer, for PMD and CD, for PMD and CD, and for CD only. PMD and a very high dynamic range, 55 dB, which is huge. You can reach distances of 300 kilometers. PMD, very high dynamic range, 65. So this is also for very long distance. And the attenuation profile, you can check the profile on the OESCL band. And a very big dynamic range. But when we launched this module, it was too good. Really too good. You know, some people told us, but this is too good, we don't need such a module for very long distances. I only want to measure 50 kilometers, and because it costs maybe 40,000 euros. You know, this is very expensive. So some people said that's too expensive and that's too good. So this is why we created the medium range dispatch. So this is based on the dispatch, but with lower spec, because in 70 or 80% of the case, the customer will need a solution for 80 km, 100 km. So the medium range dispatch will be enough. So the difference between the dispatch and the medium range dispatch is a band. For chromatic dispersion, it will measure the SCL band only, so not 1310, not the 1310 nanometer area. It will measure everything above 1416 nanometer, meaning that it will be focusing on the 1550 nanometer area. And you see the dynamic range, there is a big difference in terms of dynamic range. 35 dB, 45 and 45. So I would say that this medium range dispatch module will be offered for everything in the range of maximum 80-100 km. If it's for longer distances, you might have to go to these dispatch modules. And the difference as well is the band. If the customer says, I want to measure chromatic dispersion at 1310, the only solution you should offer is a dispatch. Because you can get a measurement at 1310, but it will be an approximation, where this is really measured at 1310. So this is, but in reality, yeah, right now I think 70% of what we sell in Europe is medium range dispatch. It is enough in most of the cases, and much cheaper than the dispatch. The light source, 3 light sources. It makes the offer a bit more tricky. The broadband source, this is a module, BBS2A, cover the OESCL. So if you offer the dispatch module, you should offer the BBS2A, because they work more or less together for the full band. And the 550 again was too good. The 550 has a standard mode and a high dynamic mode for very long distances again. But most of the case, again, they need standard distance, so the OBS 500 is enough. But it depends, so you need to ask some questions to your customer. What is the maximum distance you want to measure? What kind of fiber is it? Are there amplifiers or not? What do you want to measure? Chromatic dispersion at 1550, 1310, so you need to ask some questions to know what the customer wants to do. And then we can find the best solution. But with our solution, thanks to the 2 modules and the 3 light sources, we can answer any application. We have a solution for every application. Short distance, very long distance, medium distance, full band, SEL band only, we have every solution more or less customized. So this is a big advantage of JDSU. MTS-8000 with a medium range dispatch module, PMD, CD, attenuation profile with one port. On this side, one OTDR, and this is MTAU, this is a switch. This is a switch with 4 inputs and 1 output. I have connected a microscope and a visual fabricator. It's included. Visual fabricator is included. There is OTDR and CD PMD. You should think about the switch. This is not a standard offer, but you know it exists. And the switch will enable us to connect the OTDR, the CD, the PMD to the switch. And you only need to connect the fiber you want to test to one port. So we can go in the different page, OTDR, PMD, CD, and this is a switch. So the OTDR is connected to the port number port A, PMD and CD are connected to the port C. You can go into the link characterization, and you go into the script software. In this script software, you can select the test you want to perform. I want to perform inspection, OTDR, in auto mode. I don't want to set up anything, I'm not very good in OTDR. I want to perform chromatic dispersion and PMD. I could also say I want attenuation profile, or I could say I want OTDR in manual mode. It's up to you. You select yes or no what you want to do. In this part, you need to say if you are going to measure a cable or a fiber. So if you are going to a cable with 100 fibers, you should select cable. If it's for one fiber only, you will select fiber. And then, are you going to make unidirectional test or bidirectional test? Most of the time it's going to be unidirectional test. Then you enter the information, the cable ID, the fiber ID, the location, from the location you are measuring, and the rate. The rate can be changed afterwards, but for dispersion, you want to know if your fiber is going to pass or fail, or if you are going to be able to use it at 10 gigabit per second or at 40 gigabit per second or above. This is what you want to know with CDM PMD. Can I use my fiber for that data rate? Can I use it for 40 gigabit? Can I use it for 10 gigabit per second? So you can say this fiber will be used for 40 gigabit per second. Tell me if it passes chromatic dispersion and PMD. Then in the result you will say it passes or it fails. Then in the table of results, you can say, okay, I want to have the value at 1550, the value at the PMD value, the distance, the total loss, and so on. You select here. You can select all the values you want to appear in the table of results and put them here, and then they will be displayed in the. Okay, so this is it. Very easy, nothing to set up. In terms of hardware, so what do we have? So I hope I don't drop it again. So the OTDR is connected to port A module, one port, to port C, and the OTDR is now connected to port A of the switch. And now I have the one output port. I'm going to test this 1 kilometer fiber. So this is fiber number 1, the first one I'm going to measure. So I'm not inspecting it, I don't have much time, but at least I'm going to clean it. Okay. I connect it to the output port of the switch. And now I press start. The script starts automatically. I said that I want inspection. So now it started automatically the draw. This is a ferrule, so this is not dirt. This is the connector. So this is not dirt. This is, you should not look at that. It's because it's a metallic ferrule. These are kind of this is not looking too good. This is also bad. But the most important part is this is the core. The core looks more or less clean. It's difficult to see, but this part at least looks more or less fine. Let's say it passed. So now I press script again to keep going. So it has started the measurement at 1550. It's performing the measurement at 1550. I've not set up anything. Acquisition time 20 seconds. Now it has shifted to 1310. Checking the connection is not excellent, but it could be worse. OTDR, this is done. The unit is asking me, check source, can I start PMD measurement? No, we are not ready. So, the technician from unit A needs to give a call to a technician with unit B. This is why a talk set can be useful. We can integrate the talk set into the 8000, and the guy have a talk set. Please turn on the source. So the technician at the far end will connect the fiber, turn the light source on, select PMD, and then turn the unit on. Yes, now we are ready. I'm ready. So the guy press yes. And now PMD starts. We have not set up anything. It's made automatically. It has made the acquisition. Let's see the result. PMD. Oh, we got the value. Now ready for chromatic dispersion. Check source. Can I start CD measurement? Wait a second. The technician needs to change the mode. CD. No need to make any disconnection. Easy. Yes, I'm ready. Go ahead. And then yes, and chromatic dispersion starts. So it takes like 15 seconds or 20 seconds maximum to perform chromatic dispersion. And basically, this is it. So you see, I've been talking a little bit, but in 2 minutes, or in less than 2 minutes, we've done OTDR at 2 wavelengths, 1310, 1550. We've done chromatic dispersion and PMD with a single connection. And measurement completed, test next fiber. Yes, I'm ready. You connect fiber number 2 and you start procedure. Très bien,